Okay, we have now just finished talking about geometry. And geometry was the study of angles and the spatial arrangement of different kinds of objects when you draw them. Now we want to talk about what algebra is. So, algebra is when you represent variables with letters and then you connect the letters together to make formulas, and then you learn how to rearrange the formulas in order to solve for a particular letter. So that's what we're going to go into now, and we're going to start off with particular kinds of equations or formulas, and which are going to be called directly proportional and inversely proportional formulas. But before we do that, I have a picture here, and I want you to see if you can come up with a formula that represents that picture. So this is kind of like one of those IQ tests. What would be a good formula that represents that picture? Okay, so what is the thing that is over there on the left-hand side? That's a slice of pizza. So we could say that the size of the slice of pizza that you get is equal to what? What does it depend on? So what's the picture that's above the horizontal line there? So that's the whole pizza. So the size of the slice of pizza that you get depends on the original size of the pizza and then divided by what? The number of people that want to eat the piece of pizza. So do you recognize that picture there on the bottom? So that's the Beatles. So that's a rock and roll group from the 1960s, and that's their album cover for the Sgt. Pepper Lonely Hearts Band. And so all of the people in that picture are people that the Beatles thought were very important people. So if you want to blow that picture up, you can see people that lived back in the 1960s. That's not important though. Okay, so the important thing is this little equation that we came up with. The size of the slice of pizza that you get depends on what was the size of the original piece of pizza, and then divided by the number of people that want to eat it. So for example, if one person eats the pizza, how much do they get? So it's the size of the pizza divided by 1, which is going to be the size of the pizza. So you get the whole pizza. If there's 2 people that want to eat the pizza, then you're going to divide by 2, and then each of you get half the pizza. So this formula is actually representing 2 kinds of formulas. Okay, let's look at the directly proportional part of the equation. So do you notice that as the size of the pizza gets bigger and bigger, what is the size of the slice that you get? Assuming that this number down here doesn't change. So if you have going to hold this number the same, but you're going to make the top part of the equation bigger, what's the size of the slice of pizza that you get? It's going to get bigger. So if an equation is directly proportional, that means that its letter, its variable, is going to be on the top part of the equation. And then if it gets bigger, what comes out gets bigger. Now, let's look at the bottom part of the equation. This time, let's keep the size of the pizza the same, but we're going to increase the number of people that want to eat the pizza. What's going to come out? A smaller slice of pizza for you. So that would be inversely proportional. So when the variable is in the bottom part of the fraction, that's an inversely proportional variable, and if it gets bigger, then what comes out gets smaller. So let me give you a couple of examples of this. So in physics, we have a formula that says F is equal to ma. And so F stands for force, m is mass, a is acceleration. Not important for us. It's important if you take physics. Okay, but force causes a mass to accelerate. And let's say the A, is it directly proportional to F, or is it inversely proportional to F? Okay, now remember, we could always write this like a fraction. So this is the same thing. So if I put it over a 1, now I've turned this thing into a fraction, and now you can definitely see that the A was on the top. So if the A gets bigger, the F gets bigger. So this would be directly proportional. But there's another formula that we learn. Now this is force in general, but there's also the force of gravity. And the force of gravity, it turns out, is there's a constant, big G, which we don't care about. It depends on mass number 1, mass number 2, and then divided by the distance between them. So any two objects, mass 1 and mass 2, are going to be pulled towards each other because of gravity. So even you are like mass 1, the Earth is mass 2. So you're being pulled towards the Earth by gravity. But this thing is also being pulled towards you because of gravity. It's just that the gravitational pull down is much, much stronger than the gravitational force towards my head. Unless, of course, I had a head the size of a planet. Okay, then I would have my own gravitational field. Wouldn't that be cool? Okay, but this is the formula. Now, my question to you is, if I increase r, which is going to be the distance between the two objects, what will happen to F? And is this a directly proportional equation or an inversely proportional equation with respect to r? So with respect to m, it was directly proportional. But with respect to r, it's going to be inversely proportional. So as the r gets big, what comes out gets small. Now you can test this with a calculator. So do a 1 divided by a 1, do a 1 divided by a 10, do a 1 divided by 100. So you can do that on your calculator. And you notice as these numbers in the bottom get bigger, then the number that your calculator is spitting out is getting smaller. So with respect to r, it's going to be inversely proportional. So just keep that in your head, because as you do science, you're going to be doing a lot of formulas. And every one of those formulas is either going to be directly or inversely proportional. And one of the very first things I do whenever I introduce a new equation is I play this game. I say, what happens if I make this letter bigger than what comes out of the formula? So it's a really important skill to learn. So our next topic is going to be on properties of powers and roots, and I will see you in just a moment.